The reciprocating compressor consists of head, cooling jacket, exit valve, piston pin, cylinder, inlet valve, and connecting rod, crank and shaft. Working conditions: the pistons to be at TDC, top dead center, and move towards bottom dead center, BDC. Due to this pistons movement from the DDC to BDC, the suction pressure created the casing opening of inlet valve. With this opening of inlet valve and suction pressure, the atmospheric air enter the cylinder. Air get into cylinder during this stroke and is subsequently compressed in next stroke with both inlet valve and exit valve closed. After piston reaching the BDC, it reverses its motions and compresses the air inducted at a previous stroke. Compression is continued till the pressure of air inside become a sufficient cause deflection in exiting valve. At the moment when exit valve plate get lifted, the exhaust of compressed air take place. The piston again reaches DDC, from where downward piston's movement is again accompanied by the suction. This is how reciprocating compressor keeps on work as flow device. The reciprocating compressors. The thermodynamics analysis of reciprocating compressors. The compressor of air in compressors may be carried out in three different ways of thermodynamic process, such as isothermal compression, polytropic compression, adiabatic compressions. The thermodynamic cycle involved in compressions, the clearance volume is provided in reciprocating compressor. The purpose of clearance volume in cylinder is twofold. One is accommodate valve mechanisms, and another one is to prevent the collision of pistons with the cylinder head. In PV diagram, the process 4 and 1 success process followed by the compression during 1 and 2. Discharge process 2 and 3 and expands clearance air 3 to 4 if clearance volume is provided only. 1 and 2 adiabatic process, 1 and 2 dash polytropic process, PVN equal to constant, 1 and 2 dash is isothermal process. CV is a clearance volume. Air enter into the compressors at a pressure P1 and is a compressor up to P2. The compression's work requirement can be estimated from the area bounded by the curves of compressing cycle. The work requirement is a maximum with the process 1 and 2 adiabatic process. The engineer one shall attempt to minimize requirement of the compression's work. Ideally, compression should occur the isothermal for the minimum work input. In practice, it is not possible to realize the isothermal compressions. Reasoning in maintaining the constant temperature during the compression is very difficult. Generally, the compressors run at a subsequently high speed while isothermal compression is required compressor to run at a very slow speed, so that the heat produced during the compression is dissipated out and the temperature remain constant.